Hey Pre-Calc, Mr. Rashid here, and we're looking at today the last of the conic sections. These are parabolas. We've already seen parabolas in the first semester and also in algebra, but we're going to learn a few things about parabolas maybe you haven't seen before. So the learning target for today is going to be I can graph a parabola in standard form. So if you remember back, the most basic parabola was something like this, y equals x squared. So these things had a U shape. If I wrote y equals negative x squared, then that would be a downward facing parabola like that. So they have other things around them, other trimmings, and so we'll look at the full standard form and what that looks like for a parabola. All right. Let's start with just a picture and some new terms related to parabolas. So I'm going to draw an upward facing parabola here. And so with upward facing parabola like this, we have a point that that's the lowest point for this if it's upward facing, and that point is called a vertex. For a downward facing parabola, it would have a highest point, that would be the vertex. Then one of the things you also learned in algebra and last semester was that these parabolas have an axis of symmetry. And so anything on this side of the axis is symmetrical to any point on the other side. So we have a vertex, which is this lowest point here, and then an axis of symmetry. Now, the interesting thing that maybe you hadn't heard of before is that a parabola is formed by creating a set of points that are equidistant or equidistant from the focus and the directrix. So there's this imaginary line here, or line that we can see, and that is the directrix, and then there's a focus that's inside the parabola. Now let's see this visually. The focus, if there's a line that's drawn from the directrix, right, so this is the directrix down here. If there's a line drawn from the directrix up to the parabola, straight up from the directrix, and a line is drawn from the focus to the parabola, you'll notice that those lines have the same length. So that's the definition of a parabola. The curve represents all the points that are equidistant from the directrix and the focus. Right? So I can go in this direction, I can go in this direction, and so we'll be graphing the focus point and also the directrix line, and a convenient location would be the closest that they get, which would be straight up and down like that. Okay, let's go back. So the directrix then is this line here that, like I said, if you go straight up from that line to the parabola, and you go from that parabola to the focus, then those two lines would have an equal distance. And then the focus that's inside the parabola. Okay, so the most simple equation that we saw was y equals x squared, for example. So we're going to look at parabolas, let's say, of two types. So I'll call this parabola like a type 1 parabola. So for type 1 parabolas, they're either going to be upward facing or downward facing like this. So y equals x squared is the simplest one, but then for the parabola we're going to need some other features to describe it, and so we'll have other variables around it. And you may have seen parabolas in vertex form, so they kind of look like this: y equals a x, so this was x minus h, so y equals x minus h squared plus k. So you may have seen something like that. That was vertex form. Now, if we take and subtract k from both sides, we end up with y minus k is equal to a x minus h squared. And now what I'm going to do is divide both sides by a, or multiply both sides by 1 over a. So over here I'm going to do 1 over a, and over here I'm going to do 1 over a. These a's would cancel, so I'm left with 1 over a y minus k is equal to x minus h squared. Now instead of this 1 over a, what I'm going to do is say, okay, 1 over a is equal to 4p. So instead of 1 over a, I'm going to use this 4p. So let's replace that over here. So this will be 4p. And that is the standard form that we'll be using in this section here on parabolas. So 4p y minus k is equal to x minus h squared. So just like for circles, ellipses, and hyperbolas, we've been using hk to represent our centers. Now in the case of parabolas though, hk represents the vertex. Then this value p here is interesting to us because once we have the vertex, we also have the axis of symmetry, right? The vertex is right on the axis of symmetry. But then this p value can be used to go up towards, if it's an upward facing parabola like this, we can go up from the vertex to get to our focus using p, and we can go down to get to the directrix. If it's a downward facing parabola, we go down to get to the focus, and then we go up to get to the directrix. These 2 points, the directrix, or the value of that point directly above the focus, or above the vertex there, is equal to p, and the value just below at the focus is also equal to p. So we'll see some examples of that. So this is what I'm going to call a type 1 parabola, where it's upward facing or downward facing. The p-value, if the p-value is positive, then it opens up. P-value is negative, it opens down. So we're going to add something new now, and these are called, let's call them type 2 parabolas. So with type 2 parabolas, you'll notice that the equation, the x and the y have changed positions. So instead of x minus k squared is equal to 4p times y minus k, we have swapped the positions of the x and the y. And actually the x minus h has swapped with the y minus k. And so what ends up happening is when you do that, you get the inverse, not dealing with functions anymore here because you've got the squared. So this becomes either a right-facing parabola or a left-facing parabola. So if the p-value is greater than 0, then it looks like that, it faces right. If the p-value is less than 0, then it faces to the left like that. So the vertex is still going to be at hk. You can still get the vertex using this type of form, and the focus is going to still be behind this curve a little bit here, and the directrix is still going to be a line, straight line, so outside the parabola, away from it. And there's still going to be an axis of symmetry, just instead of x equals, you're going to have a y equals for this line, for the axis of symmetry. So some of these acronyms here, so we've got P is the distance from V to F. So for V, we're saying that is the vertex. And F is the focus. And D here is the directrix. So that's what those acronyms are referring to. Directrix. Okay, so in order to graph parabolas then, in these standard form, we will, well, they may not always be in standard form, so we may have to get them into standard form. It may involve completing the square. So move all the variables that are not off the square term that we're trying to get, move them all away to the other side, complete the square, factor out the GCF, that will be the 4p value, plot the vertex, and move p units up or down or left or right to get to the focus and the directrix. We can sketch the axis of symmetry on there too. Okay, first example then. So we have this, x minus 2 squared is equal to 8y plus 3. So we notice that the x part is squared, so this is going to be a parabola that opens up or opens down. In this case, this value here is positive, so this parabola is going to open upwards. Now to get the vertex, we take the opposite of the x, the number next to the x in the parentheses, and that there is 2. So that's negative 2. We take the positive of that, so negative 2, and then y plus 3, so we change that to a negative. So our vertex is going to be at 2, negative 3 for this problem. So I'm right here for the vertex. And remember, this is going to be an upward facing parabola like that. We're just sketching these in here. So my axis of symmetry also, I can put that in here. And then I know this is an upward facing parabola. So now for the p-value, so we take this number here, and we say that 4p is equal to 8, and that gives me that p is equal to 2. So in order to find the focus then from the vertex, I'm going to go 2 up, and so my focus is right there. And so for this problem, this here is 2, negative 3. So if I go 2 up, I'm changing the y value. And so this is 2, negative 1. That's my focus. And then from the vertex, I'm going to go 2 down. And that's going to be one of the points that's on the directrix. So 2 down then is at negative 5, so y equals negative 5. That is my directrix for this problem. Okay, let's do a few more examples here. So here's another one. Y plus 1 squared is equal to 2 times x minus 4. Now this has y squared. So if you remember back just to the most basic parabolas, we have something like y squared is equal to x. So instead of y equals x squared, we've got y squared is equal to x. So that flips the x and the y, and it's kind of a reflection over the line y equals x. And so this ends up being a left-facing or right-facing parabola. In this case, this is positive, so that tells me this parabola is going to face to the right, like this. Right? So when your p-value is greater than 0, it's going to face to the right. All right, so what else can we tell? Well, we can get the vertex from here. So our vertex, take the opposite here, so 4, take the opposite there, -1. So 4, -1 is my vertex. Then I can put in my axis of symmetry as well, and note, because this is facing right or left, in this case, it's facing right, opening right, so my axis of symmetry is going like this. Then I can draw my shape in. I'm just sketching this in. And then I use this value here to find my location of my focus and my directrix. So 2 is equal to 4p. And solving for p here, p is equal to 1/2. So just 1/2 in here, just a little bit in and a little bit out is where my directrix is going to be. And then my focus is a little ways in there. So this is my directrix, and that is my focus. Okay, so maybe the problem is looking for actual coordinates for those, so let's get those down. So the directrix, so this is a line, it's x equals something, so the vertex was at 4, so I'm 1/2 before 4, so that would be 3.5, so y equals 3.5, and then the focus would be 1/2 the other way, so I have 4.5 for my x and -1. Alright, so let's look at something where it's not nicely put together. So I have y squared plus 8x minus 48. So with these kinds of problems, move everything that's not related to y squared over to the other side. So I'm going to subtract 8x and subtract 8x. I'm going to add 48 and add 48 here. Okay, so I end up with y squared is equal to -8x plus 48. Now, we would normally, if there was other stuff there, we would complete the square, but there's nothing to do on this side because it's just y, it's already y squared, and there's nothing that needs to be done to complete the square. It is already a perfect square. Then over here, I'm going to factor out all the numbers in front of the x. So in this case, I'm going to factor out the -8. So I've got -8x, and since I factored out a negative, and this is a positive, this becomes a negative now. So -6. Okay, so that's all we need to do now to be able to graph it. We can get our vertex straight from this. Notice that that has no number, so that I'm going to use a 0 for the y coordinate, and then for my x it's going to be a 6. So my vertex is at 6, 0. So that is my vertex. And then let's plot that in there. So 6 is this an upward facing or downward facing? So I've got something that it's not upward or downward because I've got y squared here. It's going to be a right or a left facing parabola. And because this is negative, my parabola is going to be facing towards the left like this. So let's find 6, 0. That's not it. So 6, 0 is over here. Then I'm facing this way. So this is my parabola. And then let's use this number, this -8. So our -8 is equal to 4p. And dividing by my p value here, or dividing by 4, we get -2 is equal to p. And I just use the positive version of that, so p is equal to 2 here. So I go 2 this way and 2 that way. And so my focus, or my directrix, is over here, and my focus is over there. So that's the focus, and this is the directrix. Okay, so let's put some coordinates down. We have the vertex already. For the focus, instead of being at 6, 0, I'm 2 over, so I'm at 4, 0. And for the directrix, I'm way out there, and the equation for that line is x is equal to 8. Okay, let's do another one. So here I've got x squared minus 8x. So anything related to the x squared, I'm going to leave on this side. Everything else gets moved over. So I get x squared minus 8x. And we're probably going to need to complete a square, so let's leave a blank here. And then I move the negative 4y to the other side, becomes negative 4y minus 20. All right, so let's complete the square. Half of -8 is -4, squared is 16. Now to add 16 to this side. Okay, so this is x minus 4 squared is equal to negative 4y minus 4. Let's factor out the negative 4. So x minus 4 squared is equal to negative 4 y plus 1. That changes to a positive now. Since when I distribute, I get negative 4. Okay, let's put the coordinates down for the vertex. So in this case, the vertex is at x is negative 4, so it's going to be positive 4. Y is at positive 1, so it's going to be negative 1. The vertex is at 4, negative 1. Is this open up, down, right, left? So the x is squared. So it's kind of like a y equals x squared parabola, but then I've got a negative. So this is a downward facing parabola. So I'm going to have a downward facing. Then my p value here, so I've got 4p is equal to negative 4. And then solving for that, p is equal to negative 1. So I take the absolute value of that, so it's going to be 1. Then I'm going to move up and down from the vertex. So the vertex is at 4, negative 1. That's going to be a downward facing. And then the directrix then is going to be 1 above the vertex. And the focus is going to be 1 below right there. Okay, so the equation for this directrix is y equals 0. So that is the directrix. And then the focus here, equation for that is going to be just 1 below, so I'm at 4, negative 2 for my y. And then I've got the vertex there. All right, so one more problem. So when I've got my x squared, or whatever my squared term is, just keep the variables on that side, move the whatever numbers over if you can. So in this case, I do notice that it's a perfect square already. So perhaps I wouldn't move it, but if you had moved it, then you would just add 4 again to both sides. So in this case, I do notice that this is x minus 2 squared. The number was already a perfect square. Then I'm going to factor that 12 out. So this is 12y minus 1. All right, so let's write the vertex down. So vertex, in this case, is positive 2, positive 1. So 2, 1, that's my vertex. Now is this upward facing, downward facing, or right to the left? Well, the x is squared, so it's kind of like a y equals x squared type of problem with a positive p-value up there, or a value, however you like to think of it. So it's going to be an upward facing parabola from there. Okay, so I do still need a couple of things. I need my p-value, so 4p is equal to 12. Let's clean this up. So 4p is equal to 12, and p is equal to 3. So I'm 3 above to get my focus, and then I'm 3 below that to get my directrix. So let's finish this off here. The directrix then here is y equals negative 2, and the focus, that's going to be 3 plus the 2, 1. That's going to change my y value. So that's at 2, 4. And my vertex I already have is at 2, 1. All right, so that's it for this one. See you in the next video.